little bit. Red hot chili peppers, all good stuff. Hey, here's what we got. So you were looking at some hyperbola stuff. Pretty cool, huh? I'm gonna go with some red hot. How about that? So yeah, you looked at the GeoGebra thing, talked about the hyperbolas. Didn't really talk about it, just kind of showed you um, where they kind of came from as far as the animating that point around, very similar to the ellipse. Then we can investigate a little bit about what happens when you have a point on a hyperbola to the foci points, that distances. Remember that with an ellipse, that was equal to, the sum of that was equal to 2a. And a hyperbola, we tried the sum, didn't work. Did a minus, did work. So we did get a constant there. We just don't know, maybe that's 2a. I don't know. I'll take a look at it, right? And then I gave you the standard equations for the hyperbola, the center 0, 0. Hopefully kind of jotted those down someplace. So where does that leave us? Well, that leaves us with this. Let's go ahead and do some problems with hyperbolas, right? Let's sketch and let's find vertice points. So we're going to do that. So we're going to sketch. We're going to find some vertice points. Now, when you find vertice points on a hyperbola, since you just got done doing ellipses and they had 4, hyperbolas do not have 4. And that was one of the things that I found last year was that group. They kept thinking hyperbolas had 4 vertice points. I kept telling them it doesn't have 4 vertice points. It only has 2. So let's make sure that we're aware of that they only have 2. Let's see. We need to focus, right? Yeah, that's what we need. We need to talk about the focus. So I'm going to go ahead and let's go dark for our axes today, like that. And we're going to make up a little hyperbola question and do some of those right here. Let me get this set up here. We go back to that red hot chili pepper red. So let's go with x squared over 9 minus y squared over 4 equals 1. And we're going to make a hyperbola out of that. So the center is at 0, 0. That's our standard equation. I'm going to go x squared is over 9. So I'm going to go 3 on the x in either direction there. And I'm going to go 2 in the y because it's 4. So that would be square root of 4 is 2. And now I have this. And my hyperbola is going to be along the x-axis because I want to switch this one not to red. Let's go to this pretty blue here. Because the x comes first. So when the x comes first, that tells us that our hyperbola is going to open kind of along that x-axis. All right, so it's going to be more horizontal. If the y comes first, then it's going to be opening up vertically along the y-axis. So it really depends, and the reason why that makes a difference is because of that minus sign right there. That minus sign messes everything. Remember, addition's commutative. It doesn't matter whether we go 3 plus 2 or 2 plus 3. But subtraction, that makes a difference because we know that it's not commutative, and that's why you have to pay attention to which one comes first. The A and the B really don't matter. They can be anywhere. Usually A comes first. That's how we write those. But it doesn't matter. I remember with the ellipse, the A was always bigger. Not in this case. A doesn't have to be bigger. A is going to come first, but it doesn't have to be bigger. All right, let's see. How do we do this? I'll show you. It's pretty slick. What we're going to do here is we're going to make a box. All right, that's what I say. We're going to make, it's really just a rectangle, but we're going to make a box here. Okay, and I'm dashing this. I don't think it makes noise, but there it is. So then here is my start of my box. All right, now I'm going to go like this, and I'm going to draw the diagonals of this rectangle. So it looks like this. Draw the diagonals, and there are my diagonals. Now I'm ready to draw the ellipse. The hyperbola, sorry. I'm going to start at here. This is my vertice point that I talked about. And we're going to go like this. And then I'm going to do the same thing on this side. So there is the ellipse. There are these here that I'm looking at right here are not vertice points. These are vertice points. So we want to make sure we get it that hyperbolas have those two. All right, let's write them out. So vertice points. V is plus or minus 3, 0. Those are my vertice points. All right. What else do we got? We got focus points. How do we find the focus points? Well, you should hopefully you noticed that on the focus points that they were on the outside, so they are here, right? Someplace on this axis and someplace in there. So they're inside the hyperbola, but kind of outside of the vertice points. I guess I'm not exactly sure how you want to think about that. But with an ellipse, remember the focus points were kind of inside that ellipse? They still kind of are, but it's a little different arrangement. All right. So to find those focus points, I'm going to keep that as blue here. We're going to go like this. We're going to take c squared is equal to a squared plus b squared this time. So it's just like the Pythagorean theorem. Very, very similar. So that's how you're going to find the focus point. So let's do it. So we're going to have c squared is equal to 9 plus 4. That's 13. Like that. So c is equal to 13 square rooted. And it's a plus or minus. So that means that my focus points, I think I'm just going to drop them over here, is going to be plus or minus the square root of 13. That's a really nasty plus or minus, comma 0. Get rid of that for us. There we go. Plus, minus. That's what they are. So if we think about this, remember our vertice point is 3, but the square root of 13 is bigger than 3. So it is sitting right out there. So it's going to be bigger. So again, in the ellipse, A had to be bigger. In a hyperbola, A and B, they can be any size. It doesn't really matter. But this is, you always got to look at what's coming first, and here's your relationship. Let's see, sketch, vertice, focus. We did it all. Let's try another one. I'm going to scooch this up. And same idea. I'm going to draw a nice dark X and Y axis here, like this. There we go. I don't know where this stuff came from. It just shows up for me. Thank you very much. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, and another 4. There we go. So now we're ready. We're going to go ahead and do another ellipse in this red hot chili pepper color. This time I'm going to go y first. Y squared over 4 minus x squared over 36 equals 1. All right. Oh, one thing I forgot to mention. Hold on here. I'm going to scoot back up. I forgot to mention this. These slanty things, the diagonals, what do those represent? Oh man, I hope you said asymptotes, because that's what those are. Those are asymptotes. And you can find those asymptotes by simply taking the ratio of B over A. All right, so that's how you're going to find the equations of those asymptotes. All right, let's scoot on down here. We'll deal with that a little bit more as we move on, but those are definitely asymptotes, and you can probably see that. Let's do this. So we want vertice sketch. I want to sketch first, but first thing I want to do is get that y. So that's 4. So it means I'm going to go 2 in this direction here. I'm going to put got my red going there, red hot chili peppers. There's my 2. I got 6 here. Again, remember, this is A, this is B. In this case, B is bigger, but we don't care. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I'm going to make my little rectangle. So I'm going to change that color to purple, and I'm going to make my rectangle. So I'm going to start here, and I'm just going to kind of dash across here a little bit. All right, without trying to make too much noise. That's probably irritating as heck. So I'm going to come over here, drop this down, and there. So there is my rectangle, or my box. Now I got to make the asymptotes. So the asymptotes are the diagonals, and this is going to be a heck of a deal here, because I'm not sure I can get that. Oh, there's an asymptote. And here's an asymptote, so that's not too bad. All right. No, I don't do that. Come on. Here we go. Now we're ready. Well, remember, y comes first. So in this case, since y is first, then our vertice is here. All right, I don't know where in the heck that thing came from. So let's draw that. So we're going to go like this, and like this, and like this, and like this. Those other 2 points that we found that are right here in this rainbowish color, those aren't vertice points. Only these guys are vertice points. So I got my sketch done. I'm going to put my vertice point here. That's going to be 0, comma, plus or minus square root of that is 2. That's 2 up, 2 down. Focus points, now I got to find those. Remember, for that one, we're using our very common a squared plus b squared equals c squared, like that. So I'm going to add these up. 4 plus 36 is equal to c squared, which means c must be equal to 40 square root of, anyway. Let me erase this junk because that doesn't look too good. Try that again. Equals c squared. So c is equal to plus or minus the square root of 40. And again, the focus points are sitting out here someplace. So we're going to go 0, 0, plus or minus square root of 40. So there are my focus points, and there's my asymptotes, and I got everything. So there's hyperbolas, all right? Hey, since you're so good at these darn hyperbolas, how about this? What happens if the center's not at 0, 0? Then you're going to get x, come on, x minus h squared, okay, over a squared minus y, come on, y minus k squared over b squared equals 1. And we know that it's going to switch, right? It's just going to switch around if it's on the y-axis. All you have is that h and k, which is going to move that center from 0, 0. There isn't a whole lot of difference. It's very, very similar to the ellipses, not a whole lot different. So if we have a x plus 1 squared over, let's go with 9, minus a y minus, come on, 2 squared over 25 equals 1. There's my hyperbola. I'm ready to draw it. I'm going to sketch it. There we go. Sketch. Come on. Give me this number here. Here we go. We're going to start doing this. I don't know what's going on here, folks. There we go. iPad's kind of sensitive. All right. So we're ready to go. Let's do this. I'm excited. Red Hot Chili Peppers. So we got it. Let's see. Now my center is at -1, 2. So my little center is right there at -1, 2. So now I just have to be aware of that. All right. So now let's see. X comes first. So that's 3 away. So now I'm going to go 3. 1, 2, 3. Right there. There's my one vertice. 1, 2, 3. There's my other vertice. Doesn't at all look like it's sketched very good. So, but you know, that's my scales, not exactly right. 5. Now I'm going to go 5 up and 5 down. 1, 2, 3, 4, 5. Going to be right there. 1, 2, 3, 4, 5. Going to be right there. And now I'm going to make that box. Might as well stick with purple, I guess, since it didn't go. There we go. All right, so here I'm going to try to make this thing without making too much noise, so it doesn't drive you crazy. There it is. All right. Now, my asymptotes have to go through that center point there and go through the diagonals. There we go. And now I'm ready to draw it. So, x comes first, so that means it's going to sit on this thing right here. There we go. And there we go. There's my hyperbola. Ta-da, got it done. What's the vertice point? Okay, we can do it. We can do it. Vertice points. Here we go. So I take this number, so I already know what they are. It's -1. I'm going to go 3 in that direction, so that's 2 Okay, comma 2. That's one of the vertice points. Here's -1. Now I got to go 3 in that direction, so that'd be -4, comma 2. Nothing much changes. Going to find the focus points. C squared equals A squared plus B squared. How nice is that? 9 plus 25. Last I checked, that was 34. So my focus points are going to be plus or minus the square root of 34 from that center. I know they're going to be along this like horizontal. So I'm going to go, let's see, parentheses 2, negative, oh no, not 2, sorry, 1. -1, because that's that point right there. Now I'm going to add and subtract the square root of 34. And I know on the y's, nothing's happening there. It's just staying right there at 2. So those focus points are out here someplace. That's way plenty of stuff for you. So I'm going to give you some of these. I'm going to scan a part of your book in. It's going to be pretty much a similar idea. Do a couple. We'll add on some more stuff next week, and then we'll be done with hyperbolas. And I'm getting a little concerned here about how much time we got left, but we're going to try to do the best we can. Oh, hey, documents. Don't forget those questions in the document thing. For some reason today, people said it wasn't accessible. I went through and looked at it twice, and I pretty much did everything I can do. I think I got it to work now. I don't know why. Google Classroom's kind of changed some things. I don't know whether they're trying to make it easier, but anyway, I'm not sure they are. Let's see. Quiz time probably next week. Look for that. Chapter problem. Working on the details on that. I'm going to play with it, and you'll for sure get it next week. I promise you. You're going to like it. Other than that, I think that's it. No school Monday, but that's really no school anyway. But you won't be hearing from me Monday. It won't be until Wednesday, next Wednesday. Yeah, okay. Hey, have a nice Memorial Day weekend, and peace out.